Hello everyone, my name is Wojtek Kocjan. I'm an architect at Bitnami, and this is a presentation that is meant to be an introduction to what the cloud is and how you can use it for more than just running VMs. As I mentioned, I'm working at a company called Bitnami for the last 8 years. I'm an architect there, and just really briefly talking about what we do. So the company I work for, we specialize in basically packaging applications specifically for the cloud and containers. So we package a lot of open source applications. We have a dedicated tool for packaging custom applications, and we're heavily invested into Kubernetes. We have several offerings for Kubernetes. We're cooperating on Helm, which is one of the major tools for deploying applications in Kubernetes, and we have some interesting partners that we work with. So the company is 15 years old. We've always been for packaging applications. Initially, it was native applications for desktop servers, then we switched to building cloud images. We've been doing that for the last 8 years. We package both commercial and open source applications. The ones you are most probable to find would be the open source applications in cloud marketplaces like AWS Marketplace, Azure Marketplace, and Google Launcher. So we also maintain container images for a lot of open source applications, and we have a lot of Helm charts that are contributed to the Helm main repository for those applications. We're also developing several Kubernetes-based solutions for packaging and deploying applications. We have, but I'm not going to bore you with that. The only two main things I wanted to mention is we're basically a global company, we're a remote company, and my boss would be mad if I didn't tell this, but we're always hiring people. So if you like the cloud and if you want to work on it, feel free to talk to me about it. Right, so what is the cloud? So I will start with a very good description by NIST. So the cloud is on-demand self-service, meaning that you should always be able to spin up the resources you need, and it should not involve human intervention. So in the data center, you would need someone to actually go and power on a machine or put a machine in your rack. Cloud is the opposite. It has to be easy to spin up or delete services. There has to be broad network access, meaning that you have to be able to access everything from standard network. So for example, if you spin up a machine, unless you configure it otherwise, it should be available to some specific IPs, or in some other way, but you shouldn't have to be using a VPN by default or some other tooling by default to connect to it. Resource pooling means that it should be multi-tenant, so the cloud's resources should be assigned to specific tenants or specific users whenever they need it. So if a cloud has a lot of machines, if I want to use them, they should be assigned to me and I should be able to use them. If someone else needs those machines, then they can use it as long as I'm not using it, and the cloud usually has the capacity to be able to serve all of their customers, even if they have strong needs. Rapid elasticity means that I should be able to go from one machine with one CPU to dozens of machines, each having 100 CPUs within minutes, and it should not involve human intervention as well. And then measured service basically means that whatever I do in the cloud, it should be pretty easy to measure, and it should be pretty easy to find out what the cost of this will be and what the cost of it is. Meaning that if I spin up, that there is clear pricing, like hour-based or second-based pricing. And when I spin up a machine, I know if I keep it running for two years, I know how much I'm going to pay for it. And if I kill it after several hours, I'm just paying for those several hours. So quick history, quick dates. So the cloud started basically when AWS launched the cloud in 2006. The number of services back then was really, really small. So you basically had S3 for files. You had queuing system, you had a very simple database, and you had EC2, which is basically running virtual machines in the cloud, as I call it. So that was basically the beginning of it. 4 years later, Azure came up with their own cloud. Azure, in both cases, those companies were already having massive data centers to serve their own needs, and they just started selling them externally. Soon after, Google did the same thing. So in 2011, Google launched their cloud. What's interesting, Google was the only cloud that did not start with VMs. They only had VMs available since I believe 2013, but it was way after they launched. So initially it was mainly commercial versions of Google App Engine, but it's still considered part of Google Cloud. And then one other day that I put there is Kubernetes 1.0 was released 3 years ago. I put it there because I believe Kubernetes will be a major change in how we think about running workloads, because it's the only technology that allows running complex workloads, but you can run them on different clouds pretty easily. So I just put those days there. Obviously, there are way more things happening. Over time, all of them launched a huge number of services. Right now, AWS, I think, has over 100 services. Azure also has multiple services. Google is also launching things. Just 2 days ago, just yesterday, one service on Google was launched that I was able to add to my slides just today. So you may ask yourself, why would you move? Why would you move to the cloud? If you have an application running in your data center and it's working properly, why would you do this? So the first reason would be that you're able to scale and to adapt to needs, and you can do this globally. So if you have your data center is usually located in a very specific place. So let's say it's in Krakow, Poland. But then if you want to reach markets in Asia, in US or South America, you would most probably need to run your application in a different location. It's much easier to be using the cloud and then be able to move some of your resources to specific regions than to create a new data center for this. The other reason is you can scale up and down along with your load. So if you have peaks on Christmas, you can easily do this. You can also, you have way more options to scale. So for example, you can scale from a very small machine that's just, like, I don't know, 1 CPU, 1 gigabyte of RAM, to a huge machine with over 100 CPUs and terabytes of RAM. And that's a matter of minutes, just flipping one switch, and you can do this. It's also more convenient to manage, so the clouds are made in such a way that it's much easier to spin up new instances to basically clone your entire environments. There are still some things you need to do, but it's relatively easy to do this. As I mentioned previously, having a good insight into costs is really important. So when you run something in the cloud, you need to know how much it costs, and when you run multiple workloads in the cloud, because of things like tagging or other means to track your costs, it's relatively easy to manage which of your project is costing how much money. And also everything can be managed both from the console, from CLI, APIs, so whatever your preferences, you can manage it this way, and obviously CLI and APIs allow way more automation. And also one thing that is, I believe, is really important, and it's more important now than, let's say, 5 or 10 years ago, the clouds offer multiple services out of the box. So for example, if your application needs a database, it's much more convenient to take a database that's managed by the cloud, like RDS in Amazon, Azure database for MySQL, for example, in Azure, and Google Cloud SQL, and just have the cloud provider manage the database for you. Just specify the basic needs, like how much memory do you need, but all of the things like backups are basically handled by the cloud. The other thing is you may run different types of workloads. So you may run hosted applications, like I guess the Google App Engine is the most known hosted application, but AWS and Azure also have their equivalents. So if you write in a specific technology, the infrastructure running your application may be fully managed by the cloud. Similar approach with serverless, which is a newer trend, but the idea is that you basically write single small pieces of code that get run, and the infrastructure behind running them is also managed by the cloud. And also something that's more and more popular nowadays is you also have Kubernetes that is fully managed by the cloud. Google was providing GKE for a long time now, but now this year Amazon announced EKS and Azure announced AKS, which are basically managed Kubernetes as a service. So if you use Kubernetes, you can just spin up your workloads in any cloud you want and just move between the clouds. Right, so when I talk to people, I notice that a lot of people start their journey in the cloud by just running VMs. So meaning that someone finds out, hey, I have this AWS credit, Azure credits, or whatever else, I'm just going to play with it. You basically often spin up a single virtual machine and just run your code in there, which is fine. It's the same as you would do with a lot of other ways to deploy your applications. So it's a way to get started, but as you do that, you realize that there are some ways in which you can actually benefit from the cloud. So for example, you can spin up more instances. Managing the disks is much simpler. So if you see you're potentially going to be running out of disk space, You may just quickly shut down the instance, change the disk size, start it up again, and it's going to pick up the new disk size automatically, or you just need to run a few commands manually, but it doesn't involve someone physically going out and buying a new disk drive. Cloning your environment is relatively easy, meaning that most clouds basically allow you to run a few steps to make a full clone of your server, so it's much more convenient than doing this with physical hardware. You can do it with regular VMs in VMware or different virtualizations, but it's more convenient in the cloud because you don't have the problem of running out of disk space in your virtualization. And also, if you basically just need to handle more workload, you can just change the instance type, meaning that you just add more CPU and more RAM to it, and just, that's also relatively small downtime. Or you can horizontally scale to thousands of instances, assuming your application supports this. And also, one other thing you can do if you have this is you can start using some of the cloud-specific features and just migrate your application to be more cloud native over time. So, for example, one of the things that a lot of people start using is by using CDN. So you just move some of the static assets to a blob storage and just serve it directly from the cloud, not from your VM. Another option is to use CDN for caching some of the responses. So if some specific URLs are static, you may just have CDN cache those results, and also because you're using CDN, it has a lot of edge locations, meaning that even if physically your server is in the US, if someone were to ask for the same resources here in Krakow, it would most probably be responded in Frankfurt, so it's much shorter response time. The next thing that a lot of people do is they basically move their database away from the VM and just use hosted managed database solution from the cloud vendors. And another option is basically to stop using a fixed size disk and use file sharing solutions like Amazon's EFS or Azure Files to store the files in over a network protocol, so it's NFS or SMB3. But then the underlying infrastructure makes sure that you never run out of disk space when you write to those shares. So it's much more convenient. But there's a lot more of services available, and basically the cloud is a huge tool, and you shouldn't stop there. You should basically start using way more of those features. I'm not going to read this, but we're going to actually try and go through some of these. So what are the other options besides just running up code in your VM? So as I mentioned, hosted applications are one option of running your code. So if, let's say, you have a Python, Java, PHP application, you can most definitely use Google App Engine. There are also Azure App Services and AWS Elastic Beanstalk, which also allow you to run your application and just deploy new versions of the application, similar to how you would do it today, but the underlying infrastructure is managed by the cloud, so you don't have to worry about this. One downside is that the way you manage this, the features available, the supported runtimes are very different across the clouds, but you get a lot of upsides as well, so it's kind of a balance. And also the way it's managed also differs. So the way Google App Engine works is completely different than Elastic Beanstalk. But you may definitely experiment and just choose the one that you prefer to go with. Docker and Kubernetes. I believe we have a talk about what is Docker after this, so I'm not going to dive too deep into this. But as I mentioned, all of the major cloud vendors provide support for running Docker and Kubernetes in a fully managed way today. So it's just a matter of thinking whether you're interested in running on top of Kubernetes, and if yes, all of the clouds provide this. Third trend, which is more and more popular nowadays, is serverless, and I'm going to explain it in more details. The idea is that you write a simple function that is doing a single action. So in the case of web applications, you would have one entity that is basically listing your items, one entity that allows you to, let's say, edit or create an item, and then another function that would be deleting it, and then you plug it into API gateways or the equivalents in other clouds and make it available over HTTP or HTTPS. as I mentioned, I will show an example how it works in a while. So, as I said, you can also continue using VMs. But you can leverage a lot of the things I mentioned before, and also you may try to adapt some more advanced features, like if you manage to move your VM to an auto-scaling group or similar approach, you may be able to do much more with that. So I think serverless is a very interesting trend. My example is relatively trivial, but it shows how it works. So let's say you just want to return a message and just print current date time. Obviously, that's the simplest example. You may want to print something else. You may connect to a database or something, but that's all you need. So what you can do, and that's the same for all the clouds, this is just an example from AWS, is you need to write that function, and this is JavaScript, so basically it just exports a specific handler that just calls a callback saying that this is a success and this is the message to be returned. And that's the common layer between all the clouds. So maybe what parameters get passed to the function and maybe what it returns differs slightly. But the idea is that you can write a function in your language of choice, and it's going to get executed, and you don't care about the underlying infrastructure. So if there's one API call per minute, or if there's a million API calls per minute, you don't worry about this. As I mentioned, there are multiple runtimes, so this depends on the cloud, but if you're using a popular programming language like JavaScript, Python, Ruby, Go, it's going to be supported by all of the platforms. The next thing that you have to do is basically, if you want to make this available as an API over HTTP or HTTPS, you need to bind it so that it actually accepts those requests. This is also cloud specific, but it's just another step that you need to take, which is just using API, CLI, or GUI. Just specify this is the URL, this is how you pass the parameters from the query to the function, and this is how you map the output. So, for example, this function returns text, but then that binding would say, and this text has to be returned as, I don't know, text/plain or text/HTML or application JSON. There are more advanced things like content negotiation. So if someone wants JSON, it should be JSON. If someone wants YAML, it should be YAML. It's all possible. It's just that your function is relatively simple, and then you have the more higher level bindings to do this. But those functions can be called by other event sources. So for example, if you actually don't want this to be called when someone calls your API, but if you want this to be called when someone makes a change in your source code repository, if your source code repository is hosted in the cloud, you may actually have it trigger that function to be called. So you may write a poor man's continuous deployment that will redeploy your application whenever you push something to a specific branch in a Git repository. So as I mentioned, it's cloud dependent, but the differences are relatively small, and it's relatively easy to implement across the clouds, and there are even frameworks like serverless.com that allow you to reduce the number of differences between the clouds, so it's easier to move the functions between the clouds. So I try to discuss more about computing, so I show more options, but I think it's important to just go back and explain how the clouds work. So the two things that are really important is how the clouds are structured. I mentioned things like Frankfurt, like US, and different countries and continents. So every cloud has the concept of regions, and region is basically multiple set of data centers in a relatively close location. So for example, Frankfurt would be one of those regions, and I think all of the clouds have their own region in Frankfurt. There are multiple regions in US, multiple regions in Europe, multiple regions in Asia. So this allows you to choose to deploy your application closest to where your customers are. Or if you need something that spans multiple regions, you may deploy your application in multiple regions and have something global like a load balancer that works on top of these. But then each region has multiple zones, and a zone is actually a physical location. So a region would be something, let's say, within kilometers, and zones are smaller places which could be one or more data centers, but it's basically within very short location. The reason why there is this difference is that if this would be a single data center, it would be relatively easy for a whole region to go down. If you have multiple physical locations, you may have one zone that is down, but you will still have other zones within the same region that are not down. So it's easier to make your application responding to those faults of single zones. Right. So then we have the networking. So I mentioned about VMs. I mentioned about some other services available in the clouds. All of those services use the concept of virtual networks. They're often called VPCs because that's how Amazon called it first, and then it's just the name stuck. So the idea is that there is a single network tied to a single customer. So for example, to my account, and that network is within one region. So let's say it's in my account in Frankfurt, and then it has its own private IP addresses. It can be associated with public IP addresses. It has a lot of functionality to make some services available to the outside world. There is not to allow contacting the outside world. There are firewalls or security groups, depending on the naming, that allow enabling or disabling specific connectivity. And there are also more advanced features like peering, which allow connecting multiple networks. But the idea is almost every resource that you deploy in the cloud is put within a specific virtual network and within a specific subnet, which is associating that to a specific zone. So I have an example because it's difficult to explain theoretically. So this is WordPress high availability on AWS. This is something, I guess most of you know WordPress. This is a PHP application with MySQL database, and it uses file system for storing the state. So we have a deployment that is in multiple zones. So if you take a look to the left and to the right, those are two different zones. So meaning that if this data center goes down, we have a setup that is going to serve the application from the other data center. So we have down in the private subnet, which is not exposed publicly, we have WordPress running on top of Apache, which is an actual VM or set of VMs. They are inside an auto-scaling group, meaning that if the load is high enough, it's going to create more virtual machines. If the load is lower than specific threshold, it's going to remove some of the machines. Then the data, and because it's in multiple availability zones, if one of them goes down, the other one is still going to be available. That's why it is called high availability. We have the database that also has master replication. I believe this is provided by Amazon, and this database is in two zones, so it also has HA. And then we have Elastic File System for storing the data on the file system, and that is also in multiple availability zones. It's just mounted in specific zones, so internally that's NFS. And the way it works is that the load balancer is going to send a request to one of the WordPress instances. It's going to talk to the database in the local zone. Internally, they're going to make sure that the data is consistent between the databases, between the instances of the database. And that's it. Then we have, I don't think I'm going to go through all of it, but then we have the Bastion to allow SSHing to the machine, but I think that's less important. Then we have the NAT gateway to allow outbound connectivity. But that's basically it. We have two zones, and then those zones are, all of the infrastructure is replicated within each zone to make sure that it's available all the time. Security. So security is very important. The way it works is, by default, if you sign into your cloud account with, let's say, with your root credentials, which is usually your username and password that you created the account with, you have access to everything. But usually what you do is you create specific users for specific people or specific tools that are going to be issuing API calls, and you only give them specific access. And in all the clouds, it's the same, that you can define very fine-tuned rules about what resources can be accessed and what operations can be done. So, for example, if you have a tool to back up your application, it will have access to create snapshots of your disk, but it will not have access to do anything with the VMs. So it's not going to be able to delete a VM, but it's going to be able to make new snapshots. Then there are a lot of features related to network and application security. So a lot of clouds provide some out-of-the-box security scanning. So, for example, making sure that whenever you have a request with known thread and you're using tools like load balancer, those are going to be caught and those are not going to be sent to the actual application. There are additional tools that allow more fine-grained handling of these. So for example, Amazon has a web application firewall tool that allows you to deal with things like distributed denial of service protection. And then there are equivalents in all of the clouds that allow you to do this. Some of it is paid, some of it is free. The amount of security you get out of the box for free is much better than if you would be hosting your own data center. If you need the extra security because, I don't know, because you're a major company or you're suspecting that people may be trying to hack your site, you may want to get the additional security. So there are a lot of other aspects. I don't think we need to go through all of them. There is the concept of data encryption at rest and data encryption in transit. All of them need some sort of keys and secrets. So all clouds have something called the key management or the secret management, and that's actually something that Google announced 2 days ago. It wasn't manageable by users previously. It's now able to manage it on your own. But this is basically creating secrets for encrypting all of the data at rest. And it also, in some cases, it also includes managing SSL certificates and similar for encrypting the data in transit. In terms of encrypting data at rest, this means that either by default or optionally, everything like the disks, like VM disks, images for running VMs, all of the data in your storage are encrypted. In some cases, you have to opt in to do it. In some cases, it's done by default. So I believe in Google, it's by default. In Amazon, you have to opt in some cases. In some cases, it's by default as well. And then data in transit, there are a lot of solutions. I think the most important thing is that the clouds allow you to simplify it. And for example, in many cases, what people do is the load balancer is doing the SSL termination, so all of the data is encrypted all the way to load balancer. And if you design your network in such a way that this data doesn't exit the virtual network, it's safe. There are cases when it's not really the case, but this is the most important thing. Very important, maybe not. Like a big difference between managing your own data center and between managing your cloud is that you can treat your infrastructure as code. This means that instead of having documentation about how to spin up a VM or how to spin up a database, the clouds allow you to use tools like CloudFormation, like ARM templates or Google Deployment Manager to specify what needs to be deployed as an entire set of resources and just deploy this. So for example, the WordPress that I just mentioned, that can be launched as a CloudFormation template, and this means that it's going to spin up the entire virtual network for you. It's going to spin up the database. It's going to spin up the auto-scaling group with the actual machines running WordPress, EFS storing the files. So with a few clicks of a button or using CLI or API, you're able to spin up an entire WordPress deployment with all the databases. And you can use the same tools to deploy your own applications. So you can just define it. In most cases, it's JSON, YAML, or YAML with Jinja 2 in the case of Google. So it's relatively easy to define it, and because it can be nested, you can do a lot of interesting things with it. So you can define your application, and then you can define a template that deploys your application along with all of the networking. There's also a lot of tools related to monitoring, health checking. So if you want to make sure your application is running properly, you can do this at the cloud level itself. Some of it is free, some of it is paid, but basically you get the reasonable amount of data for free, and only if you need to get the additional data, you have to pay for it. Interesting thing is that all of this is usually associated with different services. So for example, a health check can be associated with the load balancer, and in that case, the load balancer would only send requests to that specific machine if that machine is actually passing the health checks. So if you spin up a new WordPress instance or a new VM with a new instance of the WordPress VM, it is only going to start serving requests once the health checks pass. So this is just an example. I think the screenshot may be slightly too small, but the screenshot basically shows how you can launch such a CloudFormation template in AWS. So this is relatively user-friendly. You just have to specify a few parameters, and then the internal tooling of the cloud is going to go in and create all of the deployments. Especially in the case of AWS, I think what's interesting is AWS has really good design for things like the deployment failing. So the way it works is that if your deployment fails, if your update of a deployment fails, you're always able to roll back to the previous version of the deployment, and it doesn't delete resources until it makes sure that everything works. And this could also be tied to the health checks that I mentioned. So it's all working together to make sure that you don't deploy a faulty version of your application. Although the formats differ, so in AWS it could be JSON or YAML. In the case of Azure, it's JSON. In the case of Google, it's YAML and Jinja too. And the specifics of the file differ between the cloud. The underlying idea is basically the same, that you, in a declarative way, you define your set of resources, you define the parameters that should be passed when creating those resources, and then the cloud takes care of figuring out the order in which they should be created, figuring out how to pass those parameters. You can include some logical functions, like if you specify some parameter, do this. If you specify a different parameter, do a different thing. And those technologies are often provide, like, there are a lot of ready-to-use examples for a lot of applications. For example, this is like the WordPress high availability. I believe that's already on GitHub. There are a lot of quick starts created by AWS. There are a lot of quick starts created by Microsoft for Azure, and there are a lot of similar examples for Google. So it's relatively easy to start using it, and it really makes deploying your application and managing your application much simpler. So as I mentioned, another thing that the clouds provide is making sure your application is optimized, and figuring out how you can use the cloud-specific functionality to reduce the load on your application itself. So as I mentioned, one thing that you can use is content delivery network, which is both being able to cache some of the files that your application serves. So if you know some of the files are not changing over time, or some of the links are persistent, you can configure it in such a way that it's cached. Similar thing with things like CSS, JavaScript, all of the assets that your application serves, they could also be cached, because usually the URL is unique for those. Similarly, you can upload some of your static files to a storage service and have them served as part of the CDN. So all of the clouds allow you to do it this way, that you can specify that the CDN either talks to a different machine or talks to a different load balancer and just caches whatever is in front of it, or you can point it to a file storage, and it's just going to retrieve the files from that storage and cache it as well or not, depending on what you want to do. Load balancer, that's pretty much obvious. So if you have more than one machine, you may want a load balancer in front of it to make sure that it's talking only to the instances that are working properly, and also that it spreads the load equally between the nodes. Obviously, there are features like sticky sessions that a lot of applications need, meaning that using specific cookies or using other means, the load balancer can detect which session was originally assigned to a specific VM or specific resource, and it's going to send requests related to the same session to the same VM. There are a lot of applications out there that need it. For some of the stateless applications, or if the state is kept outside of the machine, it's possible, but it's often the case that this is needed, so it's available. Auto-scaling. This allows any application that's running on top of VMs to scale up and down along with the demand. It's fully automated. There are different loads in which it's used. When we talk about web applications, it could be using the metrics from the queue. It could be using the metrics from the CPU usage. In the case of, for example, processing data, this could be associated with queuing systems, and just based on how much items are in a queue that is the pending things to process. This auto-scaling group can spin up more instances, or just reduce the number of instances. So it's also one of the features. I mentioned storage. So the one feature that's often used is blob or file storage. Basically, this is a very primitive storage that can be used to upload or download files. There is a lot of action, a lot of access control related to this, specifying how you can upload files, who can upload files, who can download files. But the idea is that if you have if you either are allowed to do this, or if you have a signed URL and the signature is valid, you can download or upload the file, which is really convenient, because let's say you have an application that allows people to upload files. You don't have to have those files passing through your servers or through your application logic. You can just generate a signed URL that is only valid for uploading this specific file, and then the browser can directly go and upload that file to a specific storage, and that's a very popular pattern, because this way you don't have to be passing the data around. Just send it directly to the actual storage. There are also multiple options like public, private, as I mentioned, and as I said, it could be used as the source for the content delivery network. So you can just specify that those specific URLs should map to those specific files in your storage, and you don't have to be hosting anything outside of those two things. Whenever you're running a VM, or whenever you're running Kubernetes or anything that basically needs a block-based device or a disk, there are specific services in each cloud that allow you to create and manage those disks, attach them to specific resources, or detach them. That's another type of storage that's supported by the clouds. Usually you can just specify that you want a disk, or when you launch a VM, that disk is going to be created for you. But if you need to be doing more advanced things like dealing with backups or resizing disks, you need to be interacting with that system. And then, as I mentioned, a network file system is something that's useful in some specific cases as well. So basically, this is the cloud providing some sort of unlimited storage internally, and then exposing it as known protocols like NFS or SMB3. The main difference here between network file system and block is that there are applications that require specific file system like ext4, and in this case you need to use a block storage. If the application is known to support NFS or SMB3, you can use the network file system. Unfortunately, I tried to find it, but I believe this is one of the things that I couldn't find Google supporting. Their solution is that you run a VM that just maps a big disk and exports it as NFS to other machines, and it's not as fault tolerant as those solutions, but it's still possible. Databases and data processing. So one thing I mentioned is SQL-based databases. A lot of applications use SQL-based databases like MySQL, PostgreSQL, SQL Server, Oracle. A lot of them are basically available in the clouds. So in most cases, it's either fully managed, or it's mostly managed, meaning that if it's fully managed, the database scales up and down depending on the load. And for example, Aurora from AWS scales up and down on its own. But then there are also solutions that you specify the size of the instance, meaning you specify the CPUs, you specify the RAM, and you specify the disk size, and that instance is going to be managed by the cloud, doing regular backups in the time windows that you specify are valid for doing the backups. It's going to manage having the backups for a specified amount of days, and so on and so on. All the security patches are going to be applied by the cloud vendors. So you don't have to worry about them, but you still have to worry about the disk size, and you still have to worry about how much queries you're going to be sending to that database. So those are the different options. Different clouds provide slightly different possibilities, but in all cases, it's something that you can create, and it's something you can attach to your workloads. There are also NoSQL databases. This is where the differences between the clouds get more complex, because every cloud basically has their own solution. So AWS has a solution that is using a custom protocol. Azure has the Cosmos DB, which can talk in different protocols, but internally it's a completely different database. And then Google has the Google Data Store, which also talks using a different protocol. But if you're going to be using one of them, as long as you know the protocol, they're pretty good to use. The main advantage is those databases are always fully managed, meaning that you never run into the issue that you need to be scaling it up and down manually. Those always scale along with the demand. Then there are a lot of tools related to big data, so processing large set of data. Again, some of them are managed by the cloud, some of them you have to manage partially on your own. Usually the way it works is things fully managed by the cloud are slightly more expensive, but then you get the benefit of not having to worry about them. There are a lot of other things, and I don't think this is even a complete list or even close to a complete list. As I mentioned, queues, I believe they deserve a separate mention, just because queues have historically been one of the first services in the clouds, and a lot of workloads have been done by just using the queue as a way to communicate between different machines or between different sets of machines. So often when some long-running process had to be processed, when some long-running operation had to be done or some data had to be processed, you would put it in a queue and then you would use something like an auto-scaling group to basically process it as soon as possible. Right now, those queues could be tied to serverless or different types of solutions, but they're often used to basically deal with long-running processes or dealing with data asynchronously. The clouds provide a way to manage DNS. I guess it's no different than managing DNS by any other provider. The main advantage is you can have DNS records as part of your deployment, or you can use the APIs and the same automation you use for anything else in the cloud to just manage it. And then media processing. This is something that's growing. It wasn't available a few years ago. So a lot of the clouds provide tools for video processing, because that's becoming more and more needed. Audio processing and converting speech to text and text to speech. Amazon was the one, I guess, who started with all of their solutions that they have. And then Azure also has solutions of their own, and Google has their own solutions for this. So this is a way that you don't have to. So in the case of audio and video processing, like a more classic processing like transcoding, there are dedicated services for this, so that you don't have to be worried about spinning up auto-scaling groups and managing your own infrastructure for performing those. For text-to-speech and speech-to-text, it's often useful to be able to allow, let's say, to have a button which can read an article out loud for you, and it's just connecting to an existing service instead of creating your own solution for this. There are a lot of tools related to development. So like most clouds provide their own version control system to host the code in the cloud. In some cases, it comes with a really nice UI. In some cases, it's just bare bones storage, but the upside is you can connect it to a lot of different services, and you can have actions. You can assign actions when something happens in the repository, which is useful. So it could be used to build CI/CD pipelines in a cloud-native way. What's interesting, some clouds provide some sort of IDs. So Amazon has Cloud9, which is basically an ID in the browser that is really cloud-native in such a way that it can edit serverless functions. It can edit Elastic Beanstalk applications. It can deploy those applications as well. So it's quite convenient. Microsoft's Visual Studio can be tied to, well, it has a lot of native integration with Azure, but can also be tied to make relatively easy deployments to Google and AWS as well, just a matter of installing the plugins. So I think one of the important things that the cloud offer are being able to automate everything. So as I said, everything that you want to be doing in the cloud can be done via the UI, via the CLI, via the APIs. And I guess the most important thing is whatever you're going to be doing repeatedly, you should be using the CLI or the API, even if the first few iterations take longer. Going through the UI and just having to manually click through things is going to be more problematic in the future, and it's going to be less reusable. And if you write some shell scripts or some scripts in your preferred language, it's going to be way more beneficial, especially if you're working in a team, because then everyone else can take the same scripts and can use them. And there are a lot of tools that can help with that. So obviously, we have a tool of our own, which is great. But then there are also other tools that people can use. So our tool and Packer can be used to package applications into images. Terraform is an alternative for managing deployments. It's an alternative to the solutions that the cloud providers have. but Terraform has the upside that it's more cloud agnostic. Then, as I mentioned, serverless.com, which is a framework for managing serverless deployments, and it's also making it easier to write serverless functions across clouds in a more unified way. There are many more tools. Feel free to find the tools that you need. So, any questions?
Can you post a copy of this on the internet?
Yes, sure. Pavel, can we put the copy of this on the internet?
Yeah, I think that like that's for once there is recording, right? So the recording will be one thing. On the meetup page, I guess if you want to, what we usually do it like this: we put the presentation link to the presentation there, and then usually like maybe 2 or 3 weeks after that, there would be a video uploaded on YouTube. So there would be a follow-up, information of all the things. From your experience, which one is most versatile, most easy to use?
I would say I don't want to point to one specific cloud because it's always difficult. I would say it depends on what you need. So, for example, I guess AWS has the the biggest set of services that you could use, just because they've also been the longest. So there are a lot of features that you may find there that may not be available. On the other side of the spectrum, I think Google has the lowest set of features, but then their features are more coupled together and they're more thought through. So for example, I think Google App Engine is slightly more interesting than any other hosted application solution I've seen. But then if you try to look for things like shared files, like network file system, and just being able to mount an infinite disk in your VMs, Google doesn't have it. And then it's a problem. I guess Azure has a lot of very specific services, and if you're looking for that, there are a lot of interesting options in Azure. But it's really difficult to say. I guess my recommendation would be to look for which cloud has the regions you may be interested in, and which cloud has the specific features you need. So if you need specific databases, like check which cloud is recommended for hosting those databases. If you need, I don't know, if you need to be dealing with load balancers, or if you need to be dealing with encryption, like just try to find out which one has the best proven record for doing this. So it all depends. Like we've been using AWS for the longest period of time, and a lot of our workloads are on AWS. But also because we're building and providing those applications for all the clouds, we've been involved with all of the clouds. We've been using their APIs, their UIs, and it varies. Like each cloud has their strong side and their weaker sides, and there is no single best cloud to use.
Is there any way you can rapidly generate a diagram of the topography? How can it start? That's kind of one thing I'm interested in, because when you have deployment of different servers or different functions, there's a tool that generates a picture for you.
So if you use the tools like that's a good question. If you use the tools like deployment, so now this diagram was 100 times. So if you would be using tools like CloudFormation, ARM templates, they often, and Google Deployment Manager. I am not sure about Google, but AWS and Azure come with a designer tool, which can be, in which case you can import that file, that JSON file or YAML file, and it's going to put everything in some sort of diagram that you can use. But in many cases, you need to manually move some objects around to make it more readable from the visual perspective. So, for example, if you load a lot of the templates, they're going to look correct, but it's going to be a lot of resources on the left side and a lot of resources on the right side, and something weird in the middle. And then you may need to manually move it and just put it there. But if you write up your deployment, all of those tools can import it and can show it, so you can visualize it. I think there are some third-party tools that allow you to do the same thing, either discovering existing assets or just reading the deployment definition and just showing it. But it's difficult because if you have complex enough deployment, generating a diagram that fits in a reasonable area and is readable is difficult. But there are tools that just allow you to import it, and then you need to manually improve the visual aspect of it.
I was another question about actually the similar question maybe related to strong points of particular cloud provider, so which you to some extent answered. So maybe I would ask about that. But I was thinking like it seems like that in the past it was that AWS was most, as you said, it had always the biggest number of services. So it was like the most complete solution, right?
Mm-hmm.
To many different problems, it had many different services. But as those providers tend to these days become more and more competitive, right? The number of services is growing in other providers. I'm starting to see a kind of a trend that more and more companies are going into hybrid cloud solution. So they are creating, even we in our companies for certain clients, create kind of a common layer that would allow us to, for instance, launch Kubernetes clusters within Azure, AWS, or even on-premise
Mm-hmm.
on-premise VMware. So my question is, after this maybe long introduction, do you see any interesting things happening in this space of kind of a various cloud providers unification? So kind of maybe APIs or things like that that kind of try to smoothen the differences.
I think don't see it. So I think I see the opposite, because initially when clouds came out, a lot of people were just standardizing on the VMs. And I think the reason why there are a lot of different services, different cloud-specific services provided by all the clouds, is that this makes it slightly more difficult to move between the clouds. So the reason why, I don't know, why NoSQL databases are, maybe that's not the reason, but the fact that that NoSQL databases or serverless differs between the cloud makes it slightly more difficult to switch between the clouds, and makes it, I wouldn't call it vendor lock-in, because all of those tools are open and there's nothing preventing people from writing wrappers that would just build something on top of all of it. But I think, from the cloud vendor's perspective, it is always going to be easier to have long-running workloads if they have some sort of unique features. So for example, I definitely see how Google is trying to make their GKE cluster a differentiating feature. Because even if we have EKS and AKS, I think Google has the best solution in terms of scalability, in terms of the cluster auto-scaling being there out of the box. I'm pretty sure Amazon and Azure will catch up, but this is where they feel this is where they think they're strong, their strength as a cloud is. Whereas, I don't know, AWS has a lot of features around VMs, like spot instances, which make it much cheaper to run it. I'm trying to think what else, like Aurora database, which is pretty unique, which is quite interesting project, because that's basically a custom database that is able to talk MySQL and PostgreSQL protocol, and is really, really compatible with those solutions. Like that's something unique to Amazon. And if you need a MySQL or PostgreSQL database that just scales on its own, no one else has it, or maybe not to that extent, right? A lot of the features in Aurora are not available anywhere else. So that's going to be their strength. And Azure has a lot of things around, let's say, I don't know, SQL Server. I would suspect they have the best SQL Server database there are some other different things that Azure has that are strong. Azure has a long history of building specific services for developers, like their databases could use OAuth authentication, or they could use Active Directory as well, I believe. So it was relatively simple from early days of Azure to build a database that stored data specific to users without dealing with the authentication, or just talking to the API. So I don't think that the clouds are focused on trying to find some common ground, but I think the only thing that I can see being potentially some sort of common ground would be Kubernetes. Maybe I didn't mention it enough, but that's why I put it in the history diagram, because it seems to be the only way to define complex workloads in such a way that you can run them in all of the clouds, because Kubernetes takes away the problem of assigning of data persistency by managing persistent volume claims and persistent volumes for you. Kubernetes has a unified scaling model, there are horizontal scalers for Kubernetes. There is work on vertical scaling for Kubernetes for the actual workloads, not for the cluster, but but it's also important.
But if you mention persistent volumes, you kind of imply, I guess directly, that you are putting your own, rolling out your own databases, which you run manually. You don't use, service, data as a service.
No, no, no. So I give an example of this, and data as a service is a completely different story, which is also interesting because when you take a look at Open Service Broker, which is an initiative to have a way in which you can request common sets of services, which would usually go back and create them in the cloud. So the idea is exactly that you would not be running your database, but then you would specify my application needs a MySQL database, and that's like, I don't know, some requirements like this is the amount of, to be honest, I don't exactly know how you specify your requirements for database in Open Service Broker, but the idea is that your Kubernetes cluster would have a service catalog installed. So if you have it running in Azure, you would install the Azure Service Catalog, and when your chart says, or when your deployment says, I need a MySQL database, it's going to go out, talk to Azure, and create a MySQL database. And then OpenShift, I don't know what's the plan of converging OpenShift and the service broker, but OpenShift has a similar concept they built into their Ansible playbook bundles, which is you can request a database, and that database is managed externally, and that database can actually be, I think that database has to be manually created by someone, that's the difference, but that database could be a database in the cloud, and they also have the concept of catalog of external services. So I think Kubernetes is the only tool that may even be close to creating something like this, but you still don't have all of the workloads. So you don't have, so you have SQL databases, which are relatively easy because they are available in all the clouds, but then you may not have tools like queuing that would be cross-cloud. So you may still need to be having something that is a queue based on MySQL based on a SQL database, just so it's cross-platform. So it's still difficult. But I don't know. Did that answer your question?
Yes, you answered definitely. And in a sort of unfortunate way, because I was really hoping that at some point we will see some kind of a convergence and some kind of, like similar to what we have like 15 years ago, maybe in application servers in Java, so that or maybe 20 years ago. At some point, the standard arrived, and obviously the providers had different solutions, some kind of extensions, but at least there was some common ground, right? That you could. That was kind of a sort of enforced by the industry, right? That was, I guess, one of the idea of the vendors.
I guess a lot of services overlap. So I mean, to some extent you can do it, and so one answer would be that if you use VMs are the common ground.
Yes.
Because you have a pretty much standard way of building the VMs. Like you could use Packer, you could even use Bitnami Stacksmith. Basically, there are tons of tools that allow you to build images, and a lot of those tools allow you to build cross-platform images by just providing some sort of provisioning scripts or something like that just set up the machine in the same way. You need to have the same or similar base image, but you can do it. So VMs are one common ground, and then things like load balancers, even if you define them slightly differently, they work more or less the same. Like SQL databases are common, but then there are always going to be, cloud-specific services. Like I don't think text-to-speech will ever get unified because nobody cares about text-to-speech unification.
But one thing is about that SQL Server is kind of the same API because the API is SQL or some specific dialect. So you have a dialect of PostgreSQL on Azure, it would be the same more or less as the PostgreSQL dialect on AWS. But I'm talking more about the API. So like kind of maybe a cloud formation or something like that. That would be to some extent cloud provider independent, right? So I'm not talking of course about all services, but as you mentioned, those primitives. So in terms of Amazon would be EC2, S3, ELB, maybe some containerization server like ECS, right? Because that seems like a very basic block these days. So some very basic things.
I think that would be useful, but I haven't seen anything like this happening.
Wojciech, what about Terraform?
Well, yes. So Terraform, I guess Terraform tries to solve some of it, or tries to figure out how can you build. So Terraform is a tool that allows you to deploy to multiple environments, and allows you to define it as Terraform modules, which are just I believe that it's HCL format files that just define resources. The problem is that most of those resources have to be defined as cloud specific anyway. So you can have, so Terraform tries to do it in such a way that you may have modules like a module for load balancer, and then you can plug in your maybe I'm not explaining. You can include different modules, and you can do it in such a way that that if you're deploying on AWS, you're going to be including, specific load balancer for AWS, and then if you're doing it in Azure, you're going to load the one for Azure. But I think the amount of differences makes it really difficult to define it. And then the problem is if you would be trying to build something really, really common, unless the cloud vendors would try to define similar APIs, the subset of functionality that is going to be common to all major cloud vendors is going to be really small. And then the problem is you would also need to say who you think the main cloud vendors are, because I only mentioned 3 vendors as a random thing for this presentation. But then if you don't mention, let's say Oracle, IBM, I don't know, DigitalOcean, 1&1, like if you don't mention all of the other, or let's say VMware is also trying to be, strong on being there in data centers. There is VMware on AWS, but VMware on its own is also a solution. So, like if you don't talk about those vendors, you get a lot of negative feedback about people passionate about those vendors as well. So I don't think it's possible at this point. I don't think unless someone tries to define the standard first and then try to make cloud vendors apply to it, adapt to it, I don't think it's possible.
I got a question, because Kubernetes basically can manage containers, right?
Yes.
With a bunch of scripts, you set up a container very quickly. If there's a change in demand or load, you spin up small containers. I think there's other ones like Amazon Meso, and there's also Docker Swarm, all those kind of things. Are there situations where Kubernetes is not relevant for this, or where do you think are the best scenarios for using Kubernetes? You could easily just manually spin things up, right? Well, right?
I guess the
relevant point for using Kubernetes and where are the points not to use it?
Right. So I guess whenever you choose a technology, you want to be choosing the technology that a lot of other people are using, because it's going to be maintained, even if Google, Microsoft, and all the other people contributing to Kubernetes decide to stop doing it. If there are a lot of people using Kubernetes, it's going to be maintained in 5 years from now, 3 years from now. I don't know about 10, but 5 for sure. And then Docker Swarm, I don't think like Docker Swarm, Mesosphere, and all the other tools, I don't think in the case of managing Docker containers, I don't think they took off to the extent that Kubernetes took off. There was a long period of time when people didn't know which one is going to be the main one. But I think maybe not most, but a lot of companies standardized on Kubernetes at some point, seeing that it was the one who received the most traction, the most active development. Like Docker Swarm is developed by Docker the company, but doesn't mean that when Docker the company pivots 2-3 years from now, there are going to be enough people contributing to the code that is going to be on par with Kubernetes and all the other tools functionalities. Like it's difficult to say. It's the same with any technology, with any language. If you chose, I don't know, if you chose a language that was the thing 5 years ago, it may not be the thing today. But if you chose JavaScript, you probably were right. So it's.
Another question, because 5 or 6 years ago, was a big thing was PaaS, path as a service, such as like Heroku, those kind of stuff. With this, Kubernetes, a lot of those functions already overlap. Doesn't really need for the PaaS anymore. Isn't it true?
I guess some people still want PaaS. Like hosted applications are basically PaaS. If you think about. So I mentioned the whole category of hosted applications. So like Google App Engine is basically PaaS if you think about it, because you get a platform. I'm not going to find the slide now, but basically Google App Engine is a really well-designed PaaS, and as long as you use the technology put into that specific framework. So if you either use Java, Python, I think right now it's also PHP. I don't remember what other languages it supports, but if you buy into that framework, it works well. I believe with Heroku it was more frameworks, but it was similar that you had to buy into some of the solutions, into some of the approaches they had. But those approaches work well. It's just that some people will prefer to have PaaS, but I guess having different options that are simple enough now and were way more complex.
What is pass versus? Because you mentioned that one reason that you have pass versus.
One of the big reasons for using PaaS is lightening up the administration as well as auto-scale. Because back then, infrastructure service doesn't have really this auto-scaling capability.
Mhm.
Yeah.
Especially with Kubernetes, and you can spin up a lot of containers very, very quickly. And the containers are pretty easy to manage. So what I'm saying is, what are the relevancies for this PaaS? And PaaS is such an old concept. It
Yeah.
really has much value in that. That's what I think.
But the thing with the Kubernetes, I think that this, as always, there is this problem with timing, because PaaS is some kind of a concept which is relatively, well, it is with us for some time,
Yeah.
and part of this is like fast, right? So this is a somewhat similar concept, because we have this auto-scaling,
It's probably good as fast as was Kubernetes.
Yes, but the Kubernetes started to be relevant like for the wider group of people, like maybe a year ago, maybe 2 years ago.
Yeah.
Something like that. And you still to build, and the providers managed Kubernetes platform are only starting to appear right now. Like Amazon started released beta version a couple of days ago. Sorry, the full version in the US, I think, being out of beta a few days ago. So I think that the problem is that without managed version, to have a proper installation of Kubernetes, you needed to have lots of skills. Like those skills are much easier to get today than they were 1 year ago. But like for building platform, we built a platform in Kubernetes that was to be supposed to work as, I think that it works in some extent better to many like things like, it's not exactly the same, but better to some things like AWS Lambda, but it costed us immense amount of money and time. Like maybe 20 many years to build something, because taking into account security, all those concepts, availability, all different concepts that you have around that, it is complicated on a large scale. So I think that if you are talking about a simpler installation when the knowledge is already there about Kubernetes, yes, that's simple, and I don't see a reason why you might want to use, for instance, Lambda with all its problems that it has, because it has like some problems. But for larger scale installation, it's not that easy, right? To build your own Kubernetes distribution, because that's at the end of the day that's what you need to do, right?
What I'm saying is, so there's several different schools of thought. Right? One thing is you have a vanilla VM and then you do all those things. I mean, that's kind of more or less the thing you can do with Kubernetes. I mean, there's another way, more classical way is using a PaaS kind of platform. That's another thing. And then there is the serverless functions. Serverless function is probably a really big hot topic right now. But given so much things about security, all those things, uncertainties, honestly speaking, I think the range of things you can do with serverless functions is very limited. But there are a lot of restrictions. You can do this way, and then the things exposed that way, it's not exposed correctly. There's a lot of headache, right?
Yeah.
I mean, versus like Kubernetes, which is, it's a container. Container is quite easy to understand, right? The behavior is quite easy to understand. So the value of that is very, very high. Versus PaaS is probably the classic way of doing this thing, but honestly, the more I look at it, the less the value I see of PaaS.
And it seems that would be the understanding in the industry, but it's like we are not seeing the tremendous growth. There is a lot of hype about serverless, for instance, but it's not like it's tremendously used for many, especially large-scale companies.
Yeah.
It's like they do what you say, right?
Maybe you do one or two small things like maybe image processing or voice processing, but you're not going to run a whole website on top of serverless functions. It's just not doable, let's just say that.
And on top of that, you kind of bring the complexity a level up, because now you bring your complexity out of your operating system, out of your container, because that is managed. But you have this whole orchestration, right? You have all of these parts, and you have all those events, and you need to orchestrate on a completely different level, which with a scale, when you have lots of this function, actually is more complex.
Exactly, that's what I mean. Basically with the service function, each function needs to provide some kind of access control. That's too complicated.
Yeah.
I mean, an application just provide a whole application level. That's what the container does. So I mean, you say, okay, these people can manage these, administrate these things, can add users, remove users, manage database, that kind of stuff. But if you manage a functional level, wow, there's so many things to do.
Yeah.
I mean, it's just kind of complexity just explodes basically.
So what is your opinion, Wojtek, about that, about this, especially about this usage of the fast serverless?
I definitely agree that the problem, you move the problem, so it's not like you get rid of the problem. you move the problem to a different place if you switch to fast. And if you think about, even if you don't think about the whole application, but if you think about, as I mentioned, if it's one function, then every single entity that you store in a database, like just a very simple example, should have at least 4 functions, which is create, edit, list, and get details about the specific one. So like if your application is complex enough, you're going to have hundreds of or thousands of functions, and I agree that's the pain point. In terms of Kubernetes, I think there are also some pain points. So one major pain point, as Pavel mentioned, is it's difficult unless you have a fully managed Kubernetes cluster. It's difficult to set up the cluster. It's difficult to manage the cluster. It's difficult to manage the life cycle of a cluster, like upgrading the Kubernetes version, switching between which ingress do you use, switching between the networking layers. Well, hopefully you don't need to switch networking layers. But like inside Bitnami, we're actually managing some of our containers, and it's really difficult. It's not a basic thing to be doing. The other problem is we talk about security, but container has the same problem. So if your application is using a vulnerable version of OpenSSL, you need to update that container. The problem with containers is they're immutable. This means that you need to rebuild the image, which is fine if you're actively maintaining the application, but it's going to get more complex if this is a 3-year-old application that you're not really sure if the source in your source code repository is the same as the deployed version. It should be, but you never know. And then no one has time to test it when you actually need to rebuild 20 containers with different, with newer libSSL. So none of it is easy, but I guess with Kubernetes, if you don't deal with managing Kubernetes itself, it's going to be definitely easier than managing VMs as pets, basically. So associating into every machine and doing apt-get update or yum update or whatever the command is to update it. So it's going.
And to be honest, if you think about those aspects as you mentioned, there is still no good solutions for things like security with containers, because like even recently we had this problem with in the Docker registry with one of the images that was I think mining Bitcoin, right? And it was like that's lots of stars. So no one is really checking that thing as it should be checked. So what we ended up doing things is like first you need to have your own repository, assign things, then we have runtime scanning because we never can trust even our developers when they put aside. So we have runtime scanning, and we are starting to go into side products like Quiztalk and things like that to figure out those security aspects. So I can see at some point in some range this compelling idea for some companies. Let's just take fast, and we'll just pay for the amount of invocations, and that's it, right? The amount of RAM, and amount of RAM assigned, and an amount of time that this thing is involved. And basically we can rely that there would be no security issues within the container, no issues related with some even counting billing, right? When you have containerized application for different teams, like we need to do, like different teams need to pay for the infrastructure, and calculating this is completely another thing, right? Another level of things.
Yep.
Project on its own, right?
It is. But it always is like you said, Kubernetes has downsides, fast has downsides, using VMs has downsides, like everything has downsides.
So I think like among this, like there are some certain ranges. Like if you are maybe not a too big company and you want to have something fast and you don't want to care about too much about that, like how things work, you need to create something inside, and it's not very big. Maybe fast would be a good option actually.
Yep. And for example, that's why I always liked Google App Engine. I'm not going to say this is a solution to everything, but with Google App Engine, if your application fits the model that it has, it's basically between fast and between your own application, because you still define your application as a whole. So it's not hundreds of functions that each of them run on their own and each of them is managed on their own. It's just one code base. But then they're updating the runtime, updating the operating system, everything else is done by Google, and then you just worry about your application code. So the problem is, if you try to do anything outside of the scope of Google App Engine, which is really narrow, then there's no way to do it inside Google App Engine anymore.
And how about the cost? You mentioned 3 clouds. What about the cost comparison?
They also vary. So cost is a difficult thing to guess from the top of anyone's head. I think the cost of CPU, RAM, and disk is more or less comparable. Networking is also comparable, but then in some cases you may actually need slightly different solutions to fit the same capability of your application. So, for example, in Azure, in order to have the same IOPS as in other clouds, you would probably need to be using premium disks, which completely changes how you count your disk usage, because they are counted for every 128 gigabytes, but they are fast. So this is the upside, but the downside is like if you only need 10 gigabytes of disk, you're basically paying for 110 gigabytes that you're not using. Or if you want to use 2 different disks for 2 different partitions, you have to be paying for each of those partitions separately. So it's difficult. I guess in some cases, the traffic within the same network may be differently charged. I think like if you just spin up one VM and just have it not do anything, the cost would be similar for the cheapest VMs. But if you're running really complex workload, it's really difficult to say.